Myself, Rohit Kohli. I'm currently Group CTO at NVIDIA. So I've been working in technology now since 10 years. So today's agenda will be divided into 5 things. First is what is application security, and then we will understand what is SQL injection attack. Then we will also go into there are various types of SQL injection attacks we will see, and then we will have a demo, and then how we can prevent it. For demo and all, I will tell you from SQL queries and all, and I will try that if I can pull out some online examples wherein you can try in the session itself. So see, this session is for introduction that what is an SQL injection and all. The detailed version of it you will get when you will subscribe to the course. So that's what we will be discussing today. So let's move forward. So basically, first we need to understand what is security. So see, security is something that. So let's look at this way. You made a certain system. Now that system, let's say, is a simple login module, and people come there, register themselves, and then they log in, and then they access their system. A very simple system. But when your system reaches in the hand of miscreants, people who might misuse it, then you think from the perspective of security. This is one way to go about it. Second is security is not only for prevention of malicious attacks. It is also, let's say, suppose you have 5 nodes in your complete system. And a node means that you are running different machines and you are running different application softwares on that particular system. And you want, let's say, if one system shuts down, then automatically other 4 systems are synced, and then they are able to communicate with each other. Suppose one of a system suddenly starts emitting malicious information, then all the other 4 systems will collapse because it is emitting some information which is not required, or you can say not required information. So cybersecurity basically refers to techniques or technologies, processes and practices which are designed to protect networks, devices, programs and data from attack, damage and unauthorized access. So let's decompose this particular line statement one by one. So cyber security, cyber means something that is online. That's what is known as cyber. Security, I told you, refers to the body of technologies, processes, and practices. I will start from practices. So there are certain guidelines that you should follow. For example, when you are going for web development, so there is a guideline provider known as OWASP. Right now, OWASP 10 is there. You can follow those. There are certain ISO guidelines as well. So a lot of people have provided their guidelines to follow or practices that they need to follow to prevent cyber attacks. Those are known as practices, or you can say standards. In real life, you can relate these standards with SOPs, like standard operating procedures that you follow in order to build something or any process. Then comes processes. So processes are basically your so let's say data flow. Data flow is a kind of a process. So there will be some data extraction, then there will be manipulation, and then there will be another storage or another load kind of an atmosphere. So something would be there. So let's say this is a very simple process. Now your security has to entail whole process. It is not only event based that you have to protect only that particular event. You have to look at process as a whole. So that's why it is referred as body of processes. For example, let's say there is an application running, so you need to have a security layer on registration or login, and then each resource of the application that you want to be accessed by the users. So that's what is called processes. Technologies are basically tech stacks that are used for handling cybersecurity. Tech stacks right now, blockchain is on a very huge run for providing best cybersecurity solutions. Fortunately, we are one of the best companies that are offering blockchain technologies to government as well as MNCs. And so we also have worked on cybersecurity and all. So basically, as technologies evolve, your attack procedures become sophisticated. Attack procedures are that malicious people having malicious intent try to attack your system. Now you have to prevent it. So that's what I'm talking about, technologies. I hope now technologies, processes, and practices are very clear to you what they are. And then moving forward, so a combination of these are designed to protect networks, devices, programs. So what are these networks? So networks are, for example, Currently, we are connected through WAN, that is wide area network, which is known as internet. One example of WAN is internet. It can be VPN also. Another network can be when you are inside some router. Let's say it's called as LAN, that is local area network. So suppose if I have to attack some organization, what I will do, I have to attack the complete network to get all the departments information and all. That's what we are referring here as a network. There are also hardware level attacks, such as in an Android, it is possible that someone can hijack your complete system if you are over LAN. Because see, at the end of the day, Android is an open source, so all the things are known by everyone. But now there are sophistications involved since Google releasing it. So there are a lot of sophistications involved. But if when push comes to shove, and a lot of things can happen. And then there are programmatic level of attacks. For example, people who are from programmatic background would know that there are certain things known as arrays. So let me give you an example for an array attack. Suppose you define, let's say, an array. Let's call this as array defined as a of this one. So this is basically an index. This is known as an index. So when you define an array in such a manner, what you are doing is you are telling the memory that any amount of data can come in. When you say that any amount of data can come in, basically what happens, let's say you are dealing with C. So in C, array behaves like pointers. So when you will type, let's say, let's take an example of C++. Let's say I say C out is basically to output value of A. So it will give an address of A. And if I want to take a value of A, it will take A as, let's say, 1, like such. Now, what is the flaw in this? The flaw in this, since you have not given an outbound address, outbound to array, so what it will do, it can take any value. Somewhere when you have defined this, what will happen? So suppose malicious person comes in. So what he will do, he will run this array into a loop unless and until your RAM is exhausted. So let's say, just imagine, just imagine it as int. So that means your array is a integer type whose size is 2 bytes. I'm just giving you an example. So what will happen now? Let's say if it goes for an infinite loop, then whole your memory consumption will be, so whole your RAM will be occupied, because see, in C you are storing the values first in RAM, and then you have compiled it, then you go for a database kind of a storage or a hard disk. So suppose in your code you somewhere wrote down this thing, and then a person will come who will execute a malicious code. Let's name this as malicious shell code, as shell code. What this shell code will do, it will have memory addresses of such kind of addresses will be there. So whenever you will Google around that how to execute shell codes, you will get a lot of stuff. Suppose I execute this shell code, and this shell code gets executed in the array, then it will behave like a dangling pointer. So this is again a cyber threat, because it will consume all your resources. This is at a very complex level, but I'm just trying to tell you that what is programmatic, how we have to protect our program. So what you do, whenever you are developing something, make sure that it has inbound or outbound. It's not in case of arrays only, it's for objects, and anything should have a you should not leave anything open-ended in your system. And now you will be figuring out that we write, like, let's say, for 4,000 3,000 slots. So how should we figure out? There are many tools for it. You can use many tools for static code analysis and all. For example, SonarQube. In VS Code, there are many. Vim, there are many. You can use whatever you want to. You can Google around, you will get it. So now what we discuss about is that what is the intention behind these types of attacks. So one is to make a damage to the system. Another is to gain an unauthorized access. Let's get into the shoes of black hat hacker who wants to attack your system. So let's say your account has crores of money into it, and he wants that money. So therefore, he would like to have an unauthorized access to your account. So there are two things to here. One is unauthorized access, and then removing the logs after coming out of after doing the deed, you are removing the log so that nobody is able to trace. So gaining unauthorized access, there is one way that goes through database. So that's what we will discuss when we talk about SQL injection and all in the upcoming slides. And damages, let's say you, for example, you want that system to not respond for a certain amount of time. This is one example of damage. So for one of the example of damage is DDoS, that is distributed denial of service, or you can also use DOS, that is denial of service. So that's it. So I believe now you would have understood what we mean by cybersecurity when I have decomposed each and every word for you. So as you can see in the picture here, there are application level security wherein you deal with application. So SQL injection techniques are basically application level security. Network level security is wherein you deal with data packets. Data packets are basically, right now we are having a conversation. So the data that is traveling from my place to your place is through data packets. And how they are traveling, they are using IP. Some might be using IP version 4, IP version 6, and I have a port, you have a port. So this is how it is connected, and this is how the data is being transferred. And then there is information security, wherein information security is more towards a layer level, wherein you are protecting that particular information, and you need to devise a strategy that this amount of this information I want to protect, then how you can protect that particular information. And then there are operational securities. Operational security is very clear from the name itself that you want to protect that a particular operation or of a process. Then very good strategy is disaster recovery. Let's say everything happened and your system gets blocked and a lot of things happen. Then how you have to recover from that particular system. We won't be dealing into that, but disaster recovery, people who are from developer background is very, very important because it is not only used for security, it is also used for managing crash fault tolerant systems. Crash fault tolerant systems are basically systems which suppose there is a crash in a system and your database in that particular system is gone, then how you have to recover that particular data. That is very, very important and a very interesting thing to do also. Right now, a lot of people host many of their applications on cloud. So cloud also offers a lot of disaster recovery solutions. AWS has, GCP has, GCP is Google Cloud, and Azure has, which is of Microsoft. IBM also has. And then the last is end user education, that how a particular user should exhibit the application so that they are secure. So they need to know about data privacy, they need to know about data protection. So all those things they should be aware of. So these are following web application vulnerabilities. This is not a comprehensive list, but one of the major ones. So the most popular is cross-site scripting. Cross-site scripting is basically, suppose you hosted a web application and it has a web form where you can upload a file or something. So what people do basically, when malicious intent people, what they will do, so suppose they made a virus in a .exe. Now your system will not accept a .exe, but your system can access your PDF file. So what they will do, they will embed that particular .exe in that particular PDF file, and the moment it gets executed it gets stored in the system, it automatically triggers, and then it can perform what it is designed to perform. This is one kind of cross scripting example. While now there are many techniques that you can do. Therefore, what people do right now, so whenever you attach a particular document in email and all, now there are virus scans and all. So how do they function? They basically, so first parse that particular document in a parser, and then they understand that is there any embedded things into it or not. There are many parsers market they are available. You can develop your also. So the moment the document goes into that particular parser, so what happens that it breaks down the document into XML, and the part which is not executed into XML, it inspects into it, and if it finds that there is certain code behind it, then it shows the code. The moment you figure out that particular vulnerability, then you stop it. You don't move forward. So that's how your virus scanners and all scan your document and say that it has virus and it does not have virus. Some are very much stringent, which does not allow different kind of file formats to be published. For example, zip and all. .exe you cannot directly upload. Then the second famous one is your SQL injection, which is around 18%. So SQL injection is what we will be discussing. Then there is file upload. File upload and cross-site scripting are somewhat related, but yes, technically they both are different. Cross-site scripting is basically you're executing a script, and in file upload you can embed a program. So that's what a difference between them is. Cross-site request forgery it used to happen previously. Now there are many methods. For example, CORS. CORS is a cross-region request source, wherein you define that what all methods are allowed to access a web server. So it's now protected by Web3 or W3C only. And let me tell you, whenever you face any problem understanding security and related to Web3C is the most authentic source that is there in the market. You should always refer that. And there are RFCs where you can study that how a particular functionality works. Everything on this planet is a representation of that particular thing, or these two, Web3C and RFCs. Then there are full path disclosures, remote path inclusion, authentication bypass, general bypass, open direct. So these are certain methods in the methods followed in application security or application level attacks. But majority ones are these only. XSS. XSS is basically cross-site scripting. Another is SQL injection, file upload. CSRF is not too much popular. These three is quite popular, and right now they are being exploited. So basically, this chart shows that how in across the years, how each attack, how many attacks have been happened. So you can clearly see that SQL injection in 2018 is quite exorbitant. This is SQL injection. This is SQL injection that is quite large. Now let's understand. Let's get into depth. So before understanding what is SQL injection, let's understand what is database. See, any application is designed to store data or data points. Data can be of different format. Data can be personal information, credential information, your footprints, what you are performing on a particular website. Anything that you do that can be captured is data. So if there is data, there has to be a storage. So where is the data stored? Data is basically stored in two ways. One is to store in RAM. Another place is to store in ROM. That is, one is read access memory and one is read only memory. So your hard disk or solid state drives, those are one example of that. And RAM is you know RAM you can directly push in the data. So let's divide data in these two formats. One is that you are storing in RAM, and another is you are storing in some location wherein it is written over the disk. This can be any, it can be HDD, that is hardware disk drive, or it can be solid state drive. So why I'm separating these? Because see, in RAM, a RAM behaves like a streaming engine. That you put the data, you push the data into it, it has to be consumed, and then it will remain for a temporary place. You cannot, you can store for a large amount of time, but it is useless to do that because your some X amount of RAM will be blocked. And when you store the database in your solid state drives or hard state drives, so there are a lot of systems so that you can store that particular data. Now data can be your structured, or it can be unstructured, it can be related, any format of data can be there. So when data is relatable and structured, then you always prefer a SQL kind of a structure. So SQL is structured query language, wherein you store a data which is interrelated, and it is very easy for you to perform a SQL query, or you can search any data in that particular data. So that's why you use this software to manage that particular data. So there are also a lot of examples of SQL databases. For example, MySQL, MS SQL, Postgres, or Oracle. There are many examples. I believe you people who are from development background must have used MySQL and all. Then your unstructured data or data that is not relational comes under NoSQL. That is known as not only SQL. For example, MongoDB, Cassandra, and there are a lot of other databases also. RockDB, LevelDB. There are a lot of DBs that support it. So this is what is database. Now we have understood database. Now let's understand. So suppose what happens basically, you developed an application, and I will take just a small registration login example. So that somebody registered. The moment that somebody registered, you store that particular person's information in some DB, and then that particular person logs in, and you verify that whether this person details are the same that we have sent previously to the DB or not. So this is simple application. Now, what is a SQL injection? So SQL injection is basically a web security vulnerability that allows an attacker to interface with the queries that application make to its database. So suppose, so what happens basically? So when you are registering, what are you doing behind the scene? So let's take an example of registration. So when the person registers, what you do, you make an insert queries. As you know, SQL is structured query language. So that means it is a language through which you can query the data through which you are the data and the system that you are using to manage it. So I'm assuming that we are using MySQL. So the moment the person registers, what it will do, it will insert data into table. This is what it does. So exact format is insert values into table. I hope people who are from SQL background will understand that. So suppose this is how it will happen. Insert into table. Let's say table name is registration, and then you will mention values. So let's say registration table name, you want to enter the column name. So let's say it has email ID and password, and values you are inserting. Let's say my email ID is this one and the password is 2468. So this is the registration query. At the end, this is what you do. And the moment you hit a login API or login button, what happens? It selects. So this is the query that it is executed. Select asterisk from login or let's say registration, where email ID is equal to purohit@gmail.com and password is equal to 2468. So this is what you do at the end. Now the problem here is, first of all, what now people have started doing, they don't store passwords in plain text. So they store passwords with encryption. So let's say I encrypt it in MD5, that is one-way encryption. So you enter the password 2468, but you made an MD5 value of it and then you stored in the database. And when you log in, then it converts into MD5 and then it matches that the value is same as not. Now people also have started using nonce, or you can say salts. Random salts are generated wherein you can store the password and the random salt, and then the same salt is put onto that password when you log in, and then you match it. So these are the techniques which are being used to prevent brute forcing, dictionary attacks. So password guessing is basically protected using these things. Also, people have started using CAPTCHA so that auto bot brute force attacks shall stop. So let's see what the slide says. So a SQL query is in one way an application that interacts with database. We already know that now. SQL injection occurs when an application fails to sanitize the user input data. This is one of the loopholes that attacker finds. An attacker can use specially crafted SQL commands to control web applications or database server. So basically what happens now with this query, I was able to insert a table or register, and this query is for login. So let's say login screen looks like this. So it asks username and then it asks password. Username is and password is this. So when you press enter, you are able to log in. In behind it verifies that particular SQL query. Now suppose a malicious person comes after it. So I told you that there is a dictionary attack, there is a rainbow table attack, there are a lot of guessing attacks. So suppose you have protected the guessing part. Now what you are doing, you inject something in the password or something in Corohit, a SQL statement. Let's say you execute or 1 is equal to 1. So this will always give yes. This is 1 is equal to 1 will always give you yes, because 1 is equal to 1. So these are strings right now. Let's make them numbers. So let's say or 1 is equal to 1. So if a person does this, so what will go here? Let's try to put it in query. Password is equal to 2468. Instead of this, it goes this one. So it will return that password is not invalid. Now suppose what I do, I write this one. That means in OR I am putting so what this will do, this will actually execute the statement and will give yes. And but the data that will be populated will be of all the tables or will be of all the rows. Suppose this table had 100 rows, it will give 100 rows. Now another level of check people do is they count the number of rows whenever there is a username password fill in. This is one more thing that people do. So here you will get only here you will get 100 rows, and if it was not there, you will get a row rather. So you can match. Okay, let's make a variable as num underscore rows, and we check it the value of it is one or not, and then we are able to do that. One way is this. People also scrutinize the data. That this is also important. So at the time of input, you remove these values. You suspect that this is something wrong, and then you remove these values. You put only 2468, and then you send it across. So this is how generally people do SQL injection. See, basically, many high-profile data breaches in recent years have been the result of SQL attacks, as I showed you in that particular figure also, wherein there was a graph. In some of the cases, an attacker can obtain a persistent backdoor into an organization system, leading to a long-term compromise. This is one thing that is happening. So let's move forward now. So let's understand from a very basic perspective that how SQL injection works. So this is for the people who are from non-tech background. I believe you would have understood that when I have shown you that how tech background people might have understood. So suppose you write that drive-through route and where should the bus stop, and if when should the bus stop. So this is, let's say, a simple query, a simple language which says that. So your keywords are route. So you have to describe which is the route. Then you have to describe in on that route where should the bus stop. And if you also need to specify that when should the bus stop, you have to specify. So these are the three inputs that we are providing. So the statement is that drive through route 77, that is the name of the route, and stop at the bus stop. This is where should the bus stop if there are people at the bus stop. So suppose I now inject it like this, that drive through route 77 and stop at the bus stop, but ignore the people that who are there on the bus stop. Then what it will do, it will not it will stop, but it will not allow to onboard people onto the bus. So this is what SQL injection is, and this is how it looks like. Suppose the sample statement is select asterisk from users, where username is equal to user and password is equal to password. And when you enter that Dean and Winchester's, so it gets entered. Instead of Dean, let's say you entered the same statement that I showed you, that is or one is equal to one minus minus, and password is equal to this one. So the first is a condition that will always be true, thereby it is accepted as a valid input by the application. And minus minus instructs the SQL parser that the rest of the line is a comment and should not be executed. Before delving into impact, let's understand some examples of SQL injection. So see, there is wide variety of SQL injection vulnerability attacks and techniques. So one is retrieving hidden data. So when you can modify a SQL query to return additional results, that is retrieving a hidden data. This is first one, a first example of injection. Another example of injection is subverting application logic. That is where you can change a query to interfere with the application's logic. See, these are very important. People who are from development background who are seeking to make their application robust, they should understand this. I will write it down for you. So the first one is retrieving hidden data. The another one is subverting application logic. Then another one is union attacks, and it is very it's unfortunate that a lot of people use union and joins. but it joins and you can make applications slower performance-wise, as well as the security loopholes also. So union attacks are basically you can retrieve data from different database tables. That's what union attacks are. And then there is another type of a example is examining the database. So basically, what do you do in here? You can extract information about the version and the structure of a database. And the last example is blind SQL injection, where the results of a query you control are not returned in the application's responses. This is blind SQL injection. So what is an impact of successful SQL injection attack? So a successful SQL injection attack can result in unauthorized access to sensitive data, such as passwords, your credit card details, or personal user information. And as I told you, that many high-profile breaches are basically have been result of SQL injection attacks. So the types of examples that I have told you, please go through it. I just told you superficially. It is very in-depth. While I will be discussing types of SQL injection attacks, but you should also know various examples and try to learn about them. So now we will discuss about some types of SQL injection. So SQL injection can be used in range of ways to cause serious problems. So by leveraging SQL injection, an attacker could bypass authentication, access authentication. We have already seen that how one can do so. In some cases, SQL injection can be used to execute commands on the operating system, potentially allowing an attacker to escalate or more damaging attacks inside of a network that sits behind a firewall. So basically, SQL injection can be classified into three major categories. One is in-band SQL injection, inferential SQL injection, and out-of-band SQL injection. So in-band SQL injection, or some people also call it as classic SQL injection, is the most common and easy to exploit of SQL injection attacks. In-band SQL injection occurs when attacker is able to use the same communication channel to both launch the attack and get the results. So the two most common types of in-band SQL injection are error-based SQL injection and union-based SQL injection. So error-based SQL injection is an in-band SQL injection technique that relies on error messages through the database server to obtain information about the structure of the database. So in some cases, error-based SQL injection alone is enough for an attacker to enumerate an entire database. While errors are very useful during the development phase of a web application, but I will suggest the moment you go into production, you should switch on the errors and warnings, and it should work seamlessly on the production. So you should push your code into production only when you have mentioned the method as prod, not as dev. Another thing about union-based SQLi is union-based SQL injection is another in-band SQL injection technique that basically leverages the union SQL operator to combine the results of two or more select statements into a single statement, and which is then returned as a part of HTTP response. Now we will discuss about blind SQL injection or inferential SQL injection. So inferential SQL injection, unlike in-band SQL injection, may take longer for an attacker to exploit. However, it is just as dangerous as any other form of SQL injection. In an inferential SQL injection attack, no data is actually transferred via the web application, and the attacker would not be able to see the result of an attacker in band, which is why such attackers are commonly referred to as blind SQL injection attacks. Instead, here an attacker is able to reconstruct the database structure by sending payloads, observing the web application's response, and the resulting behavior of the database server. So basically, there are two types of inferential SQL injection, which are one is blind Boolean based SQL injection and one is blind time based SQL injection. So Boolean based, or you can call it as content based blind SQL injection is a technique that relies on sending a SQL query to the database, which forces the application to return a different result depending on whether the query returns a true or false statement. Now, depending on the result, the content within the HTTP response will change or remain the same. This allows an attacker to infer if the payload used returned true or false. And even though no data from the database is returned, the attacker is typically slow, since an attacker would need to enumerate a database character by character. While on the other hand, your time-based SQL injection is an inferential SQL injection technique that relies on sending a SQL query to the database, which forces the database to wait for a specific amount of time before responding. Now, this response time will indicate to the attacker whether the result of the query is true or false. Depending on the result, an HTTP response will be returned with a delay or returned immediately. And this allows an attacker to infer if the payload used returned true or false, even though no data from the database is resolved. And this attack is typically slow since an attacker would need to enumerate a database character by character. Then comes the last one, that is out of bound SQL injection. And out of bound SQL injection is not very common. Why? Because mostly it depends on feature being enabled on the database server being used by the web application. So out of band SQL injection occurs when an attacker is unable to use the same channel to launch the attack and gather results. Out of band techniques offer an attacker an alternative to inferential time-based techniques, especially if the server responses are not very stable. And this is what makes your blind time-based attack unreliable. While out-of-band SQLi techniques would rely on the database server's ability to make DNS or HTTP requests. If people who have used Microsoft SQL Server, there is a command xp underscore .re, which can be used to make DNS requests to a server and attacker controls, as well as Oracle database has utl underscore HTTP package, which can be used to send HTTP requests from SQL and Perl SQL to a server and attacker controls. So these are basic types of or categories of SQL injections that are right now in the market. So this is how it looks like. So you can see in the URL, as I was telling you, you can send this URL to the web application. So suppose your application was example.com till index.php. Your URL was this one. People who have used WordPress and all will understand these kind of notations. So now you just need to have ID equal to 1 so that you are able to populate someone's information. Now beyond this, what happens? This information is filled in by attacker. So this information is filled in by attacker. So what it says that if version is similar to 5%, then return true, otherwise return false. So the moment it executes, it will give you the version of the database. So this is how you can get a lot of information about the database, and then you can plan your attack. So in ethical hacking guidelines, this kind of situation is known as reconnaissance. That is, you are gathering information about the system. The word is right from military only. Well, there are a lot of tools. I will suggest what you can do. You can use Kali. Kali is a Linux-based operating system that is used for security testing and all. In that, you will have SQL map. The SQL map you can run on a Linux-based system. It will tell you SQL vulnerabilities in your operating system. Let me see. It hacks planning. Please open this URL. You will be able to see how it works. So let's try it out. So what it said, this is the vulnerable application we will be trying to hack with a SQL. So here are the application logs. Okay, let's move forward. So let's try to enter username and password. So let's enter user @email.com and password. So it says that it is not working. So now they have suggested that why not you use a code. So let's try it. Password, and now I've entered code also. So it says an unexpected error occurred. So the application crashed. So let's see what happened. This is the log. Select asterisk from users where email is equal to this and password is equal to this. Therefore, it crashed. Okay. So that means this is how the application codes look like. Now let's enter the password. Are you able to see how I entered that particular statement and I was able to get into it? So I will suggest you people also should try this one. Please try at your end also to enter that and then see how the SQL statement looks like. So how you can prevent now SQL injection? SQL injection can be prevented by performing static and dynamic testing. You can also use parameterized queries and ORMs. Or ORMs are basically object relational models. So people who use MVCs, that is model view controller framework, for developing their application and all, generally ORMs come embedded into it. For example, who are working in JavaScript and Node, if you use any MVC framework like Sales, Express, anything, you will get built-in waterline and ORM. One thing very important, using escape characters in SQL queries, basically filtering the data that is going into SQL queries, or you can also say input scrutiny. So these things should be done. Enforcing least privilege on database, so users that you are connecting into your DB should have only limited access to the DB, so that even though if they gain the access, they are not able to do much around the database. And then you should enable web application firewalls. Firewall basically protects more towards network security, because it controls the flow of data or application from one port to another. So here you can control it. So that's all for today. Let me know if you have any issues.